While total search volume remains robust, the percentage of those searches resulting in an outbound click to a website is steadily collapsing. People are still looking for information, but the mechanics of how they find it have moved away from the traditional visit. While user queries hold steady, actual traffic routed to external domains has entered a steep downward trajectory. Today, 60% of searches resolve natively within AI interfaces. Consequently, when an AI overview appears, organic click-through rates plummet by up to 61%. Direct, measuring success through standard ranking metrics now means tracking an obsolete user behavior. The old SEO playbook of chasing high-volume keywords and specific link positions is no longer sufficient. This is a shift from a deterministic search model based on crawling link graphs to a probabilistic model based on semantic synthesis. Engines are no longer just matching words, they are generating answers. To maintain visibility in this environment, organizations must adopt Generative Engine Optimization, or GEO. This is the methodology used to ensure a brand is cited accurately by AI models during the synthesis process. This table compares traditional search against GEO. In the old model, the goal was ranking in search results via keywords and backlinks. In GEO, the goal is being cited directly within AI-generated answers, requiring semantic authority and precise structured data. Digital visibility now depends entirely on maximizing the probability that your content will be selected as a citation when an AI constructs its response. Generative AI ingests data through three technological vectors. The first is static training data, massive web snapshots updated periodically. The second is RAG, pulling live web content for real-time queries. The third involves autonomous AI agents navigating site trees to extract specific information. Because RAG and AI agents prioritize raw data extraction, a website's success depends on an architecture favoring machine readability over visual presentation. If a site's technical structure blocks these three pathways, the brand effectively disappears from the AI's synthesized reality. To make data parsable for these models, developers use comprehensive schema markup. Schema is a standardized code vocabulary that identifies specific entities, like products or people, and their relationships. Modern sites implement the LLMs .text protocol, a dedicated machine-ready server file providing agents a clean markdown version of the content, free from design clutter. Beyond the code, the writing itself must be grounding-friendly. Grounding refers to the technical process an AI uses to verify answers against trusted sources to prevent hallucinations. Grounding tactics involve using declarative language, including explicit FAQs and clearly identified sources. This makes information easier to parse and verify. Purely promotional copy or generic fluff reduces an AI's confidence score. If the model cannot easily extract a hard fact, it will look for a source that provides one. Technical formatting and declarative writing are now the primary factors determining whether an LLM trusts your data enough to cite it. Isolated keyword targeting fails when AI evaluates broad entity relationships, seeking comprehensive subject comprehension. To answer complex prompts, you must build topic clusters, mapping core subjects into a network of pages. A broad pillar page supported by detailed cluster pages signals true domain expertise. Deep interconnectedness, not a high volume of individual posts, is what signals authority to a generative answer engine. To verify expertise, AI models use computable trust metrics. This evolves the EEAT framework into NEET, adding a new dimension, notoriety. Notoriety measures a brand's prominence within a knowledge graph. LLMs triangulate credibility through unlinked mentions, where citations in high-authority media and discussions on platforms like Reddit and YouTube serve as primary trust signals. AI models conduct sentiment analysis across these platforms to determine how a brand is perceived. This analysis dictates the tone and framing the AI uses when mentioning your brand in a synthesized answer. Digital PR and authentic community engagement are no longer just marketing tasks. They are foundational technical factors for ranking in AI results. Because answers are generated and served natively, standard dashboards tracking web traffic and page rankings fail to measure performance in a zero-click ecosystem. This interface shows the new primary KPI, AI visibility. This measures how often a brand appears in AI-driven answers for its most important conversational prompts. Another critical metric is citation share. This tracks whether the AI quotes the brand as the primary source or simply mentions the name in passing. Teams must also monitor agent crawl activity. Tracking how frequently AI bots are extracting data from your server is a leading indicator for your inclusion in future generated responses. Attribution models must also adapt. AI-driven referrals should be tracked separately from standard organic traffic to understand how generative engines are actually routing users. Even without a direct click, achieving high visibility and positive framing within an AI answer drives significant brand awareness and downstream conversion. This fragmented environment leads to a final strategic mandate: search everywhere optimization. A website is no longer the final destination. It is one node in a larger digital portfolio that AI systems crawl to synthesize information. AI assistants pull from all public information, social media, video platforms, and digital forums to generate a single cohesive answer. Success depends on engineering a digital footprint to be consistently understood and recommended across every channel. The brands that win in 2026 will be those that align technical accessibility, content depth, and digital PR into a single cohesive engine for AI synthesis.